Okay, guys, in this lesson, we're going to take a look at geometric sequences, which is a type of exponential function. We're going to learn how to write them in recursive form as well as explicit form. Characteristics of geometric sequences. Like we were saying, geometric sequences are exponential functions. Here we have a sequence 4, 8, 16, 32, 64, and so on. When we graph these, we create a scatter plot. Geometric sequences are nonlinear. Like arithmetic sequences, do not connect the points because there are no values in between each set sequence number. Geometric sequences follow a pattern where you're multiplying a constant amount to get from term to term. The number that is being multiplied is called the common ratio. This is our R value. To identify the common ratio, you're going to divide a term by the previous term. So here we have 8 over 4, or 16 over 8, or 32 over 16, or 64 over 32. Once we reduce these, we get the common ratio of 2. So our R value is 2 for this geometric sequence. We are multiplying each term times 2 to get from term to term. The domain, just like in arithmetic sequences, is our counting numbers. These are the position or location numbers of each term. So you have a first position, a second position, a third, a fourth, and so on. So your domain in all sequences is going to be 1, 2, 3, 4, and so on. The range is always going to be the sequence itself. So the range for this sequence is 4, 8, 16, 32, 64. Remember, with our sequences, instead of f of x or y, we're going to use a sub n. This is our output. This is the sequence terms. Instead of x, we're going to use the variable n. And with all of our sequences, our n value is going to be 1, 2, 3, 4, 5, and so on. In this example, our first position number is 4. Our second number is 8. A sub 3 is 16. A sub 4 is 32. And A sub 5 is 64. So here's our function table that we could graph. Recursive formula or recursive form is just to define a sequence. To define a sequence, you always need to know the first term. You need to know where to begin in your sequence. Then you need to know your common ratio for our geometric sequences to know how to get from term to term. So pause the video and jot these in your notes. Remember, n minus 1 simply means the previous term. So in order to get the current term, you need to know the previous term and multiply it by the common ratio to get the current term you want. Explicit formula is that user-friendly formula that lets us be able to identify any term in our sequence. So let's write this in our notes. To get any term, a sub n, you simply take your first term and multiply it by your common ratio. Again, pause the video and jot these in your notes. Here is all of the components that you need to know about a geometric sequence using the example that we've been looking at. You can see that the recursive form is simply our first term, a sub 1 is 4, and then our common ratio is 2 times the previous term. So this is just a fill in the blank. You will need to know the first term and your R value. Everything else stays the same. When we write it as an explicit form, we have a sub n, any term we're trying to find, equals our first term times the common ratio raised to the n minus 1. Remember, n is the term position. So if we wanted to know the sixth position, we would plug 6 in for n. Let's take a look at this sequence. First of all, let's find the common ratio. How are we getting from 3 to 9, 9 to 27, 27 to 81, and so forth? We can see that we have 9 divided by 3 is 3, 27 divided by 9 is 3, and so forth. So this common ratio is times 3. Now let's complete our function table. Our first term is 3, our second term is 9, our third term is 27, our fourth term is 81, and our fifth term is 243. The domain. Remember, the domain is the counting numbers. The range is the sequence itself. And remember, our sequence continues, so we will put our ellipsis ... The recursive formula. So here is our little cheat sheet. Remember, all it is a fill in the blank. So a sub 1, in order to define a sequence, you need to know the first term, and then you need to know the pattern. Our pattern is R, and then we have times a sub n minus 1. For the explicit formula, to find any term we want, we need our first value, 3, times the common ratio, 3 raised to the n minus 1. And again, if we wanted to find the 7th term, the 8th term, the 20th term, we could plug that number in for n and then do order of operations. Let's take a look at this sequence. We can see that we are decreasing 800, 400, 200, 150, and so forth. We can see that it's 400 over 800, 200 over 400, and so forth. So we are multiplying by 1/2 to get from term to term. So our common ratio is 1/2. Our n values, our first number is 800. Our second term is 400. Our third term is 200. Our fourth term is 100. And our fifth term is 50. The domain, again, is our counting numbers. 1, 2, 3, 4, 5, and so on. The range is our sequence. 800, 400, 200, 100, 50, and so forth. The next one will be 25, and so on. Our recursive formula. A sub 1, the first term in our sequence is 800. Then we need to know the pattern. The common ratio is 1/2 times a sub n minus 1. Our explicit formula, to find any term, we're going to have a sub n equals 800 times the common ratio, 1/2, raised to the n minus 1. where we can locate any term that we want in our sequence. So we're going from -2 to 8, 8 to -32, and so forth. Whoops. Let's back that up. So I'm going to have 8 over -2. That's going to give me -4. So I'm multiplying by a -4 each time. So this is times. This is not minus. That would be an arithmetic. So I'm saying times -4 times -4 and so on. So our common ratio or R value is -4. 1. Our first term is -2. Our second term is 8. Our third term is -32. Our fourth term is +128. Our fifth term is -512. Our domain, again, our counting numbers. 1, 2, 3, 4, 5, and so on. Our range is our sequence, -2, 8, -32, 128, -512, and so forth. The recursive formula, we need to identify the first term, which is -2, and then we need to know our common ratio. Our pattern from term to term is multiplying by -4 times the previous term. Our explicit formula to find any term is going to be our first term number, -2, times the common ratio, -4, raised to the n minus 1. Here we are given the recursive formula, and we're going to be able to locate a few of our terms. So the sequence, the first term is 5, and we are multiplying by 3 to get to the next term. 5 times 3 is 15. 15 times 3 is going to be 45. 45 times 3, 135. And we can just say ... from there. Our domain, 1, 2, 3, 4, and so forth. Our range, 5. And I usually tell folks that there's no set amount of terms that you need in a sequence as long as the reader can identify the pattern, and they would be able to tell you the next term in a sequence. Okay, now let's write this in explicit form. A sub n equals our first term, which was 5, times the common ratio of 3 raised to the n minus 1. Here we have a sequence, and our first term starts with 1/2, and our pattern is doubling. So when we multiply 1/2 times 2, we get, 1/2 times 2, that gives us 1. 1 times 2 gives us 2. 2 times 2 gives us 4, and so forth. The domain, 1, 2, 3, 4. Our range is the sequence. We started with 1/2, and we doubled. The explicit formula, a sub n equals our first term, 1/2, times the common ratio raised to the n minus 1. Now we're given the explicit formula, and we need to write the sequence. So the explicit formula, remember this part is our first term, 5. And then our multiplier is 3. 5 times 3 is 15. Times 3 is 45. Times 3 we said was 135. Our domain is 1, 2, 3, 4, and so on. Our range is 5, 15, 45, 135, and so forth. The recursive formula. You need to know the first term, and you need to know the pattern. Okay, here is our last one. The first term of our sequence is -8. The pattern is multiplying by 2. So that's going to give us -16. -16 times 2 is going to be -32. -32 times 2 is going to be -64, and so forth. Our domain, 1, 2, 3, 4, and so on. Our range, -8, -16, -32, -64, and so on. Recursive formula. We need to identify the first term, and the reader needs to know the pattern. So the pattern is our common ratio is multiplying by 2 times the previous term. Now let's take a look at 2 examples of word problems. Remember, with sequences, there is no such thing as the 0th term. So we do not have a y-intercept. The population began with 20 species. So that's at the very beginning. That's at like year 0. Each year the population doubled. So in year 1, we have double 20. So that's going to be our first term. So in year 1, we have 40 species. So explicit formula, remember, says you need to know your first term, which is going to be 40, times the rate, which is doubling, raised to the n minus 1. Our domain is 1, 2, 3, 4, 5, and so on. Our range starts with 40, and we want to know the 5th term. So we can plug in. Sorry about that. So we want to know the 5th term. So we're going to plug in 5 for n. So we have 2 to the 4th, and 2 to the 4th is 16. And now we just need to multiply 16 times 40. But let's just go ahead and double here. So our second year, we have 80. Our third year, we have 160. Our fourth year, we have 320. And then in our 5th year, we're going to have 640 species. So that's just the answer to the question after 5 years. Zeke was helping his dad pick up the rocks in the yard. Zeke picked up 3 rocks on his first term and placed them in the bucket. Next, his second term, he picked up 6, placed them in the bucket, and then he picked up 12. So he's going to continue at this rate. So the explicit formula. So in this case, the first term is 3, because in turn 1, he has 3 rocks. So each turn that as he picks these up, each time he picks them up, that is going to be our domain. So he picks up 1 time, then he has a second round of picking up rocks, a third, a fourth, and so on. So the first time he picks up rocks, so the range is our rocks, how many rocks, and the domain is how many turns or rounds he's picking up. And he is doubling, and it's the second time he has 6, and then 12. And so our pattern is, so he starts out with 3 rocks, and he doubles each time. And then he's going to double 12, which is 24. He's going to double, so his first term is 3, his second is 6, his third term is 12, his fourth is 24. His 5th time for picking up rocks is going to be 48. His 6th time is going to be 96. So this is the answer to our question. It's going to take him 6 times or 6 rounds to pick up 96 rocks in that one round. So wowzer. I hope this video helps you.